Okay, so come to the question number 8. Question number 8 is very important. It is given that in right triangle ABC, right angle at C. So first thing is given that ABC is a right angle triangle where the right angle is this one, angle C. Okay, ABC is a right angle triangle and the right angle is the angle C. Next one is M is the midpoint of the hypotenuse AB. So since C is the right angle, that means AB is the hypotenuse, it is given that M is the midpoint of AB. That means AM and BM will be equal. And next thing is given that C is joined to M and produced to a point D. C is joined to M and produced to a point D such that DM is equal to CM. Again, it is given that C is joined to M and produced to the point D such that this DM is equal to CM. Okay. Point D is joined to the point B now. This point D and B are joined. Okay. So we have to prove here 4 things. So first one is triangle AMC is congruent to triangle BMD. So AMC, this one is congruent to the triangle BMD. These two triangles which we have to prove congruent. Okay. Second one is angle DBC is right angle. That angle DBC is also 90 degree. We have to prove. Third one is triangle DBC. Triangle DBC is congruent to the triangle ACB. And fourth one is the side CM is half of AB. These 4 things we have to prove. So remember one thing, you have to prove the second one first, then first one at first the number 1, then 2, then 3, then 4. Okay, you cannot prove 3 before 2. Most of you do this thing wrong here. Okay, so at first prove 1, proof 2, proof 3 and proof 4. Therefore they are given in sequence or given in the form 1, 2, 3, 4. That means you can easily prove 3 at first, okay, before proving 2, but this will be wrong. At first proof 1, next proof 2, next proof 3, next proof 4. Okay, so question number 8. So directly we prove first one is given triangle AMC congruent triangle BMD. So in triangle AMC, this one AMC and triangle BMD. So these two triangles AMC and BMD. In these two triangles, the first thing is given that you have to write that AM is equal to BM. And the reason is since M is midpoint, you have to write this within bracket midpoint of AB, because they are directly not given that AM is equal to BM. They are given that M is the midpoint of AB, so that is why AM is equal to BM. So next one is look at this one, these two angles. They are vertically opposite angle. Therefore, angle AMC is equal to triangle BMD. They are vertically opposite angles. Okay, and the next thing is directly they are given that CM is equal to DM. DM is equal to CM. So at first we taken this triangle, therefore we write CM is equal to DM, which is given. That means side angle side. Okay, so therefore triangle AMC is congruent to triangle BMD. Triangle BMD, which is SAS. So first thing we prove here side angle side. Okay, so we have to prove the second one. Second one is very important actually. So you can give number 1. So number 2, since triangle AMC congruent triangle BMD, in bracket right from 1. Okay, so therefore if these two triangles are congruent to each other, then this angle, look at this one, ACM will be congruent to triangle BDM. Why? because CPCT, these two triangles are congruent to each other, therefore this angle will be equal to this angle. Similarly, this angle will be equal to this angle, or this side will be equal to this side, CPCT. Okay, so you can write one thing here, right? At first, suppose you write AC is equal BD CPCT and give number 2 here. AC equal to BD, we have to use these things later. Okay, and important thing is this one. You can write angle ACM is equal ACM, this angle is equal this one, this angle is equal to this angle BDM. Okay, write CPCT. Okay, now look at carefully. ACM, instead of ACM you can write ACD. Okay, same thing. ACM and ACD angle will be the same angle representing this angle, or instead of angle BDM you can write BDC, same angle will be recognized. Okay, clear? So that means this angle and this angle are equal, BDC this angle and ACD this angle. So like this, these two angles are equal. Okay, if these two angles are equal, then these two lines must be parallel to each other. That means these two angles are what? They are alternate interior angle. This one. That means this angle and these angles are equal. Okay, understood? Again I am repeating this one. In this two triangle, this angle and this angle are corresponding parts of two congruent triangle. Instead of ACM you can write ACD, and instead of BDM you can write BDC. So these two, if these two angles are equal, these two angles are forming by these two sides and this transversal. That means these two are alternate interior angles, and if these two angles are equal, then the two sides are parallel. Which are, you can write which are alternate interior angle. Alternate interior angles. Okay, so therefore side AC is parallel to side BD. Okay, AC and BD are parallel. Our target is to prove this angle is also 90 degree. Okay, so now look at this one. AC parallel BD. Suppose these two lines are parallel and this one is a transversal. Okay, that means these two angles are what? Sum of these two angles are 180 degree, co-interior angles. Like this one, these two lines are parallel, this one is a transversal, then sum of these two angles is what? 180 degree, and they are known as co-interior angles. So same thing happen here. This BD and AC are parallel. Okay, this one is a transversal. Look at this one, BC. BC is the transversal. AC and DB. DB and AC parallel. This is the transversal. That means sum of these two angles must be equal to 180 degree. That means they are co-interior angles. So AC parallel BD, BC is the transversal. Okay, so therefore angle ACB plus angle DBC equal to 180 degree. Within bracket you just write co-interior angle. Okay, but AC, the value of ACB is given to us, which is 90 degree. So 90 degree plus angle DBC is equal to what? 180 degree. So that means angle DBC equal to what? 180 degree minus 90 degree. Okay, so that means the value of DBC is equal to what? 90 degree. Okay, so this one is the DBC is a right angle, so that's right. Therefore DBC is a right angle. Okay, so now we will prove the second one. So third one is what? We have to prove triangle DBC congruent triangle ACB. So in triangle DCB and not DCB, sorry, DBC. In triangle DBC and ACB. In triangle DBC and ACB. So look at this one, DBC, this one, or ACB, this one. Okay. In this two triangle, look at this one. AC is equal to BD. Already proved. Okay. AC is equal to BD. That means you can write this one from this one. DB is equal to AC. Within bracket you write from 2. Okay. Again, angle DBC is equal to angle. Already we write angle both DBC and ACB both are 90 degree. Okay, and DBC is equal to angle ACB, both are 90 degree. Right? Both are 90 degree. Okay, and now look at BC, this side. From DBC triangle BC and from ACB triangle CB. So BC is equal to CB. Don't write BC equal BC. Okay. Same side, but you have to follow the actual pattern. BC CB. This was BC CB. BC equal to CB. You have to write common side. So ultimately, these two triangles are congruent by side, angle, side. So therefore, triangle DBC is congruent to triangle ACB, and within bracket the criteria is SAS. Side is what? DB, this triangle, and this side. Okay, SAS. So the third proof is this one, and from this thing you have to write on CPCT which thing we have to use in question number 4. Now question number 4. Question number 4, we have to put CM equal to half of AB. Okay, before writing the question number 4, you just write a CPCT. Okay, since DBC is equal to ACB, that means corresponding part, this side DC and AB will be equal. So therefore, side DC is equal to side AB, which is CPCT, and give number 3. Okay, so now come to the question number 4. Okay, question number 4, they are asking that to prove CM equal to half of AB. So now, again, CM is equal to DM, which is given. Look at this one. CM and DM are equal. Okay, and when you add CM and DM, then you will get CD. Okay, that means this CM is half of CD or DC. Suppose this value is 2 and this value is 2. And CM and DM are equal. And if we add CM and DM, then you will get CD. That means CD is what? 4. So you can say that CM is half of CD. Okay. So therefore CM is half of CD. You can write. Okay. Implies. So CM again, but CD, that means DC and AB are equal. So instead of CD, you can write AB. And within bracket you just write using 3. And question number 4 is that CM is equal to half of AB. So CM is equal to half of AB. So proved. This question is very important. Okay.